Hello class, so in this video we're going to be talking about estimating the area under a curve. So let's say that you're given a function, like f of x equals x squared, from 1 to 3. So this is interval notation right here, and this is the other standard notation. So we want to find this shaded area over here. So let's talk about first of all why we'd even want to do that. So the area under a curve tells us a few things. Because if we look at a curve in general, we can see that if we go over a certain number of units, then we can go up. If we go over the same number of units, you go up. Actually, in this case, a different number of units upward, and so on. So these green arrows, what they tell us is the rate of change of the function. And the thing is, change gives us stuff, right? So in this case, we're going to see that when you change, you gain more height in the function. So the easiest way to see the actual application of this is with velocity functions. So let's say you have a function, I don't know, it looks like this. It represents speed. If you actually look at the area under this, that tells you the distance traveled from point A to point B. It's a little bit more complex than that, but the general idea is that I can go over that in more detail in a different video. So accumulation is the main reason why we're going to be doing this stuff, this area under a curve. So how do we do it? It's easy to take areas of things like this. There's a rectangle, base times height. Or triangles, 1/2 base times height. Or circles, pi r squared, things like that. So let's actually apply those types of things into here. Specifically, let's start with the rectangle. That's going to make things a little bit easier as we start looking at these. So when you make rectangles, you got to figure out, first of all, how many rectangles you want. An easy thing to start out with is just 4. It's not too many, not too little, and we can kind of see what's going on with it. So remember, area of a rectangle is base times height. So we're going to have to find some sort of base and some sort of height, and we can put those together. Okay, so let's figure out what is the base of each of these rectangles. So if we look over here, that's going to be a certain number of units. So let's see, that's 1, that's 2. This is halfway in between, so that would be 0.5 then. So there's a notation that we generally use for this. We call that delta x. So delta is the Greek letter D, capital 1. It stands for change in the sciences. So when you see delta anything, that just means change in something. So here we're changing x's. 0.5. So that's what each of these little bases is going to be. You can figure out what that's going to be by looking at the interval. We're going from 3 to 1, so we can find the distance between that, and we're dividing it into how many rectangles here? 4 of them. So divide the distance into 4, we get 2 over 4, which is 1/2, or 0.5. Okay, so how about the heights, though? This is also important, right? Because we need the height in order to actually calculate the areas. So if we look at the function and the height, we notice that the function actually can tell us the height. So if we know the x value over here, we can figure out what the height actually is. So find the function value. Same thing for all of these. So let's find those x values. If we just look at this, we can easily see that we have 1 as one of our heights. That's just that right there. And then if we go delta x over, then we have 1.5. Delta x over again, we got 2. Delta x over again, we got 2.5. And that's the last one that we're doing, because in this case, what we're doing is looking at left-hand points. So look at this interval that we have. We have 4 rectangles. Notice that we're using 4 different intervals, which I'm going to divide in blue over here. And we're using the x value that is on the left-hand side of the interval. So this is called a left-hand sum. Just going to write that right here. Left-hand sum. And the abbreviation for that is actually going to be capital L with a subscript of 4. So that just means left with 4 rectangles. Okay, anyway, so if we know the x values, then we can define the actual function values, right? So we can find the y values, otherwise known as the heights. So they're at f of 1, f of 1.5, f of 2, and f of 2.5. But there's actually something interesting about that, because notice that when I was talking about these 4 in the first place, I was saying we get 1, and then we add 0.5. I'm going to write delta x here, actually. And then we add, to this, we add another 0.5. In other words, 2 delta x's. And then we get another delta x there. So we get 1 plus delta x, 1 plus 2 delta x, and 1 plus 3 delta x. In other words, we have f of 1 plus, and then we have f of 1 plus delta x, and we have f of 1 plus 2 delta x, and then we have f of 1 plus 3 delta x. These are all the heights. Alright, now let's actually put this into the sum itself. So if we're looking for L sub 4, what we're going to look for is base times height. So the base, I'll just color code that. Base is delta x, and the height is going to be, the next height that is going to be f of 1 plus, no, just 1. And then we're going to add the base again, which is delta x times f of 1 plus delta x. And then I think you probably can see the pattern by now. So I'm just going to write that real quickly. So 1 plus 2 delta x, and then delta x times f of 1 plus 3 delta x. Okay, now I'm going to actually plug in the values here after also factoring out that delta x, because we can do that since it's in common. So I'm going to use fractions here. I know that I was originally using decimals, but you'll see why it's more useful in this case. Okay, so f of 1, that's going to, well, we'll plug in those values later. And then that's f of 1.5 is 3 over 2, and then f of 2, and then f of 2.5 is 5 over 2. Okay, so I'm going to stop the color coding now and just go straight into finishing this up. So 1/2 times f of 1. What is f of x again? I'll remind us that f of x is x squared. So whatever is in there just gets squared. 1 plus, that's going to be 9 over 4, plus 4 plus 25 over 4. Okay, and then let's see, we can get a common denominator, which is clearly 4 here. So 1/2 times the quantity, okay, that would be 4 plus 9, plus, and then 4 times 4 is 16, plus 25, all divided by 4. And then simplifying that all together, we get, let's see, so 4 and 16 make, actually 16 and 25 make 41. 41 plus 9 is 50. 50 plus 4 is 54. So we get 54 over 8. That can reduce. So let's see, if we reduce that by 2, we get 27 over 4. And that is the left-hand approximation. Okay, so I'm going to go through the next two fairly quickly, just because I don't want the video to get ridiculously long. So if you need to review how this went, just rewind the video, watch again, and yeah. So next one. So notice here, we're going to do things a little bit differently, but similarly. So it's still going to be 4 rectangles, and we have our little bases here. They're all the same. However, the heights are significantly different than last time. Now we have these ones. So how are we going to find the values there? So given what we did last time, let's just first get a name for what this is. So notice that last time we used things on the left-hand side of each interval. Now we're using things on the right-hand side. So this is called a right-hand sum. And it'll be R sub 4 because it's going to be right-hand with 4 intervals. Okay, so delta x, that's our base, right? So base, delta x in this case is still 1/2, so I'll leave it as that. And then now we need the heights. So what are the x values? Here, instead of starting at 1, we're starting at 1 plus delta x. And then we go 1 plus 2 delta x, and then 1 plus 3 delta x, and then 1 plus 4 delta x. In other words, 3 over 2, or 1.5, and then 2. 5 over 2, or 2.5, and then 3. Okay, so let's just put that into an actual sum form, and notice delta x is the same no matter what, and you're going to multiply that delta x to each of the function values, right? So you can just factor that out to the front at the very beginning. So I'm going to do that, and we got f of 3 over 2, sorry, that's not a comma, that's a plus f of 2 plus f of 5 over 2 plus f of 3. Alright, and then simplifying that, we get 9 over 4 plus 4 plus 25 over 4 plus 9. And then just getting common denominator, we got 9 plus 16 plus 25 plus, let's see, 9 times 4 is 36. And then we got that all over 4. Okay, let's see. So, easiest way to add this, well, we remember that that's 50 plus 36. 50 plus 36 is 86. 86 over 8. So let's just divide that by 2 again. And we get 43 over 4. Alright, so let's analyze what we actually did here. So here we have 1 plus delta x, 1 plus 2 delta x, plus 3 delta x, plus 4 delta x. And then going back up here, what we have is we have 1 plus delta x, 1 plus 2 delta x, 1 plus 3 delta x. So we can see that there are already some differences, right? We start with, this is basically the same as saying 1 plus 0 delta x, right? Because 0 times delta x is going to be 0, so we just have 1 left. So let's actually try to write this into sigma notation. If you need to review sigma notation, we can look at, just look at the video that came before that says sigma notation. Okay, so if we're going to look at the left-hand sum, we have the summation. I like to use k because it's a little less ambiguous, or if you're using m and n, it's kind of hard to say them differently or hear the difference. So I use k. It's just easier to differentiate. So we have delta x times f of 1 plus, let's see, if we wanted to do the same thing that we did up there, where we had 1, we thought of it as 1 plus 0 times delta x as the first thing, plus 1 plus delta x. We can think of that as 1 plus 1 times delta x, and then 2 delta x, and then 3 delta x. If we think about it like that, then the thing that we're putting into the function, which is these 4, is going to be 1 plus, we can say that's just k delta x, starting with k equals 0, and going to, what's the highest one? 3. And if we want to do the right-hand one, that's almost the same, except you don't have this, and instead you go up to 1 plus 4 delta x. So if we just let that be delta x, and then did this, we can actually still keep the argument or sequence inside here the same. We just change the index. So we're just starting with k equals 1 instead of k equals 0. And I go into 4 instead of 3. So notice that when we do this, we can actually generalize some stuff. Instead of going from 1 to 4, let's just say we have a certain number, n. There's also the other reason I don't use n down here, because it gets used up there in formulas. So this is one way you can really look at this. That on left-hand Riemann sums, so this is called a Riemann sum in calculus. On left-hand approximations, you can go from k equals 0 to n. N is just the number of rectangles that you have. So I'm going to write that real quickly over here. So for any number of rectangles that you're going to use, you can actually just use this. And notice also then for delta x. Delta x, we're looking at an interval from somewhere to somewhere else, right? And we're dividing it into n rectangles, n even rectangles, evenly spaced that is. So if we just look at the distance between the 2 points and divide it by the number of rectangles, we're able to actually get delta x. So delta x is just going to be whatever this is. So that's where that little formula comes from. Okay, so I know the video has been going on quite a while. I'm just going to do a really quick example with 8, and then that'll be it. All right. So here, we're going to use L sub 8. So I'm just mostly going to set this up, and then you can just calculate it out yourself because this is going to get long. So since it's left hand, we're going to start with k equals 0, and then go to, if we look at the thing that we got up here, this formula. Oh, whoops, that's n minus 1. Sorry about that. We go to n minus 1, so 7. Because we want 8 rectangles total, so 0 to 7 is going to give us that. Alright, so we have delta x. I'm just going to write delta x and then f of 1 plus k delta x first. Okay, so what is delta x? So we're going from 1 to 3. So just real quick note down here, delta x equals from 1 to 3. So 3 minus 1 over how many rectangles? We got 8. So 2 over 8. So 1 over 4. So we can put that there in the delta x spot. And f of 1 plus k times 1 over 4. So we can go a bit further with this because we know what f of x is. And that'll be more helpful. So let's just do that. 1/4. And then I'm going to look at this as k over 4. That'll just make things a little bit easier to deal with. So f of x is 1 plus whatever's in there squared, right? So we have 1 over 4 times, okay, first thing squared plus twice their product. So that'll be k over 2 plus second one squared. And if you just simplify that by distributing that in, then we can get a final little thing here. Or you can actually just distribute that out because remember the summation only cares about k. If there's no k, we can just take it out by multiplication. So that one cannot come out. Alright, so this is the easiest way and best way to just simplify it. So just get it to there and then you're good. The video's gone on long enough, so hopefully this is helpful, and see you in the next video.